Good afternoon, students. We're looking at how to draw a line and shading with an inequality. And those that were not here on Friday, you should look at the questions on page 75, number 11 to 22. The examples in the textbook are excellent. So that is 73, 74, 75. I am going to do one here just to give you a taste for what we need to do, give you a feel for it. And there is some graph paper, so Mr. Halupa has that. You may find that useful as you're doing some of the questions, and especially the ones that we're going to be doing today. Let's put it that way. Let's start with this question. I did do this on Friday, so it's a recap for those that are here. I'm asking us to draw this line, and if you can remember, the -4 is my y-intercept. The -3/4 represents my slope. My y-intercept of -4, I can plot that right away. And then I'm going to use my slope. If it's a negative slope, it means it's going in this direction. Right? So the direction is important. The sign tells me direction. Up 3/4. Here's my line. Now this one is just to show you how to draw a line. All right, so we need to draw the line. And I think what I had done was modified that a little bit, but let's just change it right here. So let's say that this is no longer equal to, let's say that it is less than or equal to. If it's less than or equal to, you have a solid line like I have drawn. It's less than that line, so that means the values of y have to be less than the line. So if I look here at my y, you can't see what I'm marking. All right, here at the y, that's what we're looking at. And I want a point that is less than here. That's here. So this is the region I need to shade. And so when we're shading, we're going to shade that whole region where all the y's are going to be less than that line. Now, this says less than or equal to. That's why we have a solid line. If I was to change it and I said, what about where y is greater than -3/4x minus 4? Now I've changed the question. And it looks like, well, the line didn't really change any, but it did. It's not or equal to. And so in order to show that, when we do dots, we'd have a hollow dot. In this case, we're going to have a slotted line. And I'm just going to change the line property. So I have a slotted line, and I'm going to shade above the line. And then that would be y is greater than -3x minus 4. So that's the principle of what we were looking at on Friday. We need to have that same information today. There's one thing I didn't do. I'm going to give myself some, check my lines. I want to make sure that I have some solid lines with double-headed arrows because they're good. I'm going to change, that's a slotted line. We'll change this one. So it is a slotted line. And we'll make sure it has double-headed arrows. We'll make sure it's a regular size. So it should give me a couple of lines to choose from. And I'll make sure that this one is done as well. Sorry about that. I should have done that ahead of time. Okay. Okay. I'm still thinking I'm recording. I am. We're good. Okay, so I have two lines here, and I'm going to try color coding them for you. So we have y is greater than or equal to -2x plus 4. and I have y is less than x minus 2. So we're going to graph these on the same grid paper. And I'm going to color code them. So I'm going to first of all draw the blue line, blue, so my y-intercept is 4. My slope is negative 2. Give myself enough information, then I can draw the line. I have a little bit more. Because it is an or equal to, which line am I going to use? I'm going to use the solid line. Okay. And it says that it is greater than or equal to that line. So when I go to shade, I'm going to shade above that line. I'm going to shade in blue to go with the blue line. So the y values are all bigger than the y values on that line. Okay, so the blue part's done. Now let's look at the red, and it has a y-intercept of negative 2. It has a slope of 1. Enough information, draw my line. Do I use a solid or a slotted? Slotted, because it does not have an or equal to. And then it says shade below that line. So I'm going to take in my shade, and I'm going to shade the region below the line. If they were equals, I would be saying that my answer is where the two lines meet. In this case, my answer is where the two shades overlap. Do you see where the two shades overlap? Two shades overlap here. This region is the answer. The points that lie on this line are included in the answer. The points on the slotted line are not included in the answer. It's good practice to show whether that point of intersection is included or not included. When you put a circle around it, it's not included. All it takes is one slotted line, then it's not included. Okay, so my answer is graphical. We're not going to necessarily put that into any type of mathematical statement. The mathematical statement actually comes from when you take these two equations together. Let's try another one. Plot these two lines. Use the inequalities effectively, knowing if you have a solid or a slotted line. I like working with everything in y equals form, so I'm just rearranging my equations. Be careful, as in this one with the red, that when I'm dividing by the negative 1 to get a positive y, my inequality switches. That's a tricky one. I'm going to plot my points. I'm going to choose slot it. I'm going to graph below the line. Sorry, I mean shade below the line. Be careful here, just make it perfect for Kit. Learned that on Friday. All right, so there's the blue. For the red, y-intercept is negative 1. I have a positive slope. I'm also going to have a slotted line because it's not or equal to. and it says to shade below that line. It's less than that line. The answer is where the two shades overlap, and it should be a little bit more purpley. That's the answer. You should, for good practice, circle the point of intersection when it is not part of the solution. Okay, word problem. Oh, sorry, this one's not quite the word problem. Must be the next question. Let's look at this one. I'm giving you the answer. What's the question? Giving you the answer, can you write the question? Mr. Halupa is going to pause it here as you figure out this question. When we're dealing with this, you need to be able to identify or write the equation of a line. Remember that an equation of a line, y is equal to mx plus b. I'm color coding again. I'm going to calculate my slope. My slope rises 3, goes over 1, so it's a 3x. My y-intercept is negative 3. Now I probably shouldn't have put the equals in. What I'm going to do is I'm just going to leave this blank for a moment. Then we'll figure out what has to go in there. I'll do the red one while I'm looking at it. Same thing, I'll just leave that blank so we know what we're looking at. My slope's negative. My slope is negative 2 over 3x plus 3. My y-intercept is 3. So now we need to see what our inequalities are. So in my red, it's shading this way. It's below. It's a not or equal to, so it's just a less than. In the blue, I'm actually shading above the blue line. So it's a greater than, it's a solid line, so it's a greater than or equal to. So here is my system of linear inequalities that will represent that picture, that graph. You're going to see a question like that. I like these work backwards type questions. Here's the word problem. A company makes snowmobiles and sea-doos. They're very similar, so it makes sense. One's a winter season, one's a summer season. In one day, the assembly line can produce no more than 20 snowmobiles and no more than 30 sea-doos. As well, no more than 40 total can be made in one day. This is an introduction to linear programming. And we're going to be looking at that Friday and early next week. So we're really working with word problems. We need to dissect it, see what the information is. We're working with word problems just like in computer programs. We need to look at what are our variables, right? Declare them. What are they going to represent? So let's let x equal the number of snowmobiles. And we'll let y equal the number of sea-doos. Now notice I am using two different colored pens. I'm going to be drawing different lines, so I'm color coding for you. Now let's go to, I probably didn't need them here, but we're going to look at them with our word problems. We can produce no more than 20 snowmobiles. And snowmobiles was in blue. Let me get the blue pen. So x, no more than, means it has to be less than or equal to 20. For sea-doos, there's no more than 30. So y has to be less than or equal to 30. And there's no more than 40 total. So that means the number of snowmobiles plus the number of sea-doos has to be less than or equal to 40. So we're going to have to look at how to graph these three lines. So here's the grid paper that I'm looking at. I could have 10, 20, 30, 40. Right. Let's do everyone is 5. That makes this easy. And I'll use the same grid on the horizontal as I do the vertical axis. So this is going to give me 10, 20, 30, 40. X is less than or equal to 20. Well, you can use a solid line. Less than that is this region. Y is less than or equal to 30. So I graph that line and I shade below that. So you're seeing already that we have what I would call a bound region. Then I'm going to plot the line y is equal to negative x plus 40. It has a slope of -1. So there's that line. When I shade that, we'll shade it with the dark gray. It's harder to see it. I might have to make that color a little darker. Let's see if it even allows me to do that. Not too dark. There we go. And I think from back there you can see the answer. I'll just make sure that you understand that that answer is in this region where all the shades are. So now it's not just my system of 2 inequalities. You can have 3, or we could have 4. It gets a little messier. A lot of the times we're going to see it with 2 or 3. Now what you need to do is practice it. So we'll be assigning some questions from the textbook for you to be able to do and to be able to understand. Some of them you're going to be, what's the question? Because the answer, you have to figure out what the question was. Anyway, hopefully there's no problems. You have a test tomorrow, and I'll be available Thursday at lunchtime. Just a reminder to a couple of you that we're meeting on Thursday with logarithms. Okay, thank you.